Okay, now let's look at part H at the scenario analysis. So we're going to says do scenario analysis based on the assumption there's a 25% probability that each of the six variables itemized in part F will turn out to have their best case values as calculated in part F. 50% probability they will have the base case and 25% that they will have the worst case. So what we're going to do is take your best case variables. So your sales price up here we found the best case variable for our sales price was 260, right? That was or 390, excuse me. The worst case would be 260. The best case is 390. So our best case up here is 390. Our worst case is 260. Okay, so then you take best case of your variable cost, that would be your lowest variable cost. Worst case would be your highest variable cost. In the best case of unit sales, worst case of unit sales, fixed cost, weighted average cost, equipment cost. Okay, so what you need to do is take each one of these right here, your best case of all your variables, and take it up to your very beginning of your inputs. And put them in your inputs up here. All the best case. Okay? Then you will arrive at a new net present value with those best case scenarios. Okay? Copy and paste, not the cell, but the value right here. And you can see if you can see what's pasted here, and it has all the decimal points. It's taken out, but we've taken all those out. So here's your NPV. Do that for each one. Of course, your base case is what we found already. That's base case, and then your worst case. Now, the next thing you need to do is find your expected NPV. So it's the sum of your probabilities times the NPVs. So you just take your best case NPV times the probability of that NPV plus base case times that probability plus worst case times its probability. It's just a weighted average is all it is. So that gives you an expected NPV. Now you need to find now we're going to find our standard deviation. The first thing you do is find the standard deviation, squared deviation times the probability. Here's the formula for that. It would be for this one, it would be your expected, or your NPV for this best case, subtract your expected NPV, all squared. You can see, you put the little caret top one squared. Okay, that needs to be in parentheses, and then this whole thing needs to be in parentheses. Then after you set that, subtract it from that, squared, multiply it by your probability. Okay, and that should give you this, or something close if you use the same amount of decimal points. Do the same thing for this one, except now it's this, your base case NPV, subtract your expected NPV, PV squared, multiplied by your base case probability. Okay, then once you get down to here, sum all those up. Sum all those up. Then come down here and you can take the square root of those. You can do it just like this, the square root, caret top to 0.5%, that's the square root. Or you can use the square root function, which you'll find under your formulas here. And then you find the coefficient of variation, and the coefficient of variation is your standard deviation right here divided by your expected NPV. You don't have to do any graphs for this, but be sure and answer the questions. Alright? Good luck. Have fun.